All right, we're going to go ahead and get started for today. So, good afternoon, everyone, and thank you guys for being here. Welcome to our October installment of ENERCALC Office Hours. As I guess everyone who's here knows, we have transitioned from sessions to Zoom as our platform for ENERCALC Office Hours. So, we have just a couple of housekeeping items before we start the program today. Before we get going on the program, I want to start with a quick sound check. So, if you direct your attention to the bottom of your Zoom window, in your browser or desktop app, you'll see the chat tool. If you're able to hear me right now, just go ahead and throw a thumbs up emoji in the chat and let me know that you can hear. And we'll just make sure of that. Or you can use the reactions. That would be fine also. Perfect. All right. Thank you guys for confirming that. And before we get on to the rest of our housekeeping items, we also want to do a sound check for our primary speaker. So once again, if you can hear Mac's voice here in just a moment, go ahead and throw a thumbs up emoji, use the chat, or give us a reaction.
Hello, everyone. This is Mac. Welcome to another session of Office Hours.
Perfect. All right. So now that we have our tech checks out of the way, we are going to go ahead and disable the chat and we'll move on to some introductions and get going with today's program. So my name is Seth Roseworm. I'm Senior Structural Engineer and Software Developer here at ENERCALC. Our presenter for monthly ENERCALC Office Hours program is Mac Elterhony. As most of you know, Mac is a Senior Structural Engineer here at ENERCALC, and he kind of splits his time between providing technical training for ENERCALC customers, working with the ENERCALC engineering team on the specs and behavior of our software, and also helping maintain a presence for ENERCALC at national events. So Mac is also a founder and managing principal of Elta Design Group, which is a specialty structural engineering firm based in Oklahoma City. And he's been an ENERCALC customer for about a decade, so he has a lot of great insight about the needs of our customers. For anybody who's new here this month, ENERCALC Office Hours is meant to provide direct communication between us and our users, and we do several different things in each month's session. Mainly, we showcase new features and updates from ENERCALC. Mac goes through optimized workflows and how-to tutorials. We also sometimes answer previously submitted questions that were sent in writing. We do live Q&A with the audience. And if there's ever a question that's too involved or requires deeper digging and troubleshooting, this will be a better fit for our support team so they can investigate concerns, look under the hood, and see what's going on with your question. As a minor point of order, you will notice that everyone's microphones are muted just to make sure we don't get any echo or feedback while Mac is presenting. As I mentioned, we do have open Q&A at the end of our session today. So to submit a question for today's Q&A, use the Q&A dialog in the lower dashboard of your Zoom window, and we'll be able to go through those questions. If you ever experience audio problems at any point during the session, you can check your audio settings as we noted in that chat message. Or you can simply refresh your browser, close out, and rejoin the session. If you ever need to rewatch today's program or share it with somebody, the recordings are posted to the Office Hours playlist on our ENERCALC YouTube channel, which you can also access from enercalc.com. And with that, I will go ahead and hand it over to Mac to get us going on our program for today.
Thank you, Seth, for the introduction, and hello, everyone. Welcome to this month's installment of the Office Hours program. And we'll go ahead and start our session with a brief overview of the overall agenda for today. So we will be covering ENERCALC latest build, register for office hours to get notified, what's new in ENERCALC, and of course, we'll get to the meat of the presentation, which is wood shear wall design, and we will wrap it up with live Q&A. So we have a couple of housekeeping items that we need to take care of. So the first thing is, are you using the latest build of ENERCALC? So if you open your ENERCALC and look at the very top, you will be able to identify your current build of ENERCALC. And we want to make sure that you get notified of any new updates. So you're always taking advantage of the newest features that we implement. We have these updates occurring monthly, and we're working hard on that. So if you click on this update icon, this window will pop up, and you just make sure that you check this option right here that automatically checks for updates at program startup, so you never miss an update. Next, for users on build 2023-830, to 2024-228. The feature to notify you of the availability of new updates does not function properly. So for those who are affected by this, the user will need to do a manual update one time. And you can do this from either inside of ENERCALC or through the website at enercalc.com/users. For, of course, builder users on build 2024-304 or newer, you don't have this issue and you would not have a problem. So you can do the update very easily by following these steps. You just click on the update icon and you click on this button right here. This will bring you to our website where you just need to download the latest updater. Once you click on that, you'll download the file, you run it, and voila, your ENERCALC is up to date. And of course, step 3 is always go back and make sure that this is checked so you never have to miss any update in the future. And for the record, the most current build as of today of ENERCALC, the most current build is 2024-10.3, and this was released October 3rd, just a few days ago. I also encourage everyone to register for the office hours program so you can get email notifications directly to your email. Typically, the email address that we have on file is for the IT department or maybe an admin that manages the office licenses. And these notifications, most of the time, the notifications about these educational sessions, they typically go to either the admin person or go to an IT person, or maybe go to one engineer and they just stay with that one engineer and the other engineers won't know anything about these available resources. But if you go ahead and you register, you will be able to get notified specifically about office hours directly to your email. And this is, of course, available to everybody. This is open to everybody, and you can, of course, unsubscribe anytime you'd like. So, with that being said, you can register by going to enercalc.com/office hours, or you can just go directly to our website, which is enercalc.com, and you can navigate to it by clicking on the for our users and then get help support, and then you click on office hours, life, monthly, education, and Q&A. So when you click on that, it'll take you to the registration page, which is very straightforward. You input your email address, your name, and of course, if you're an active subscriber, we ask you for your license number. If you're not an active subscriber, you don't have to put anything there. And then you click on the remind me about the office hour session. And that's how you would be able to sign up. And lastly, at the bottom here, you see the information being updated regularly about the next office hour session. So you're always in the loop. You can you can see right here, that would be the date of the next session. Right here will be the link to attend. And you can also click add to your calendar and it will download a calendar file that you can then import into your calendar, whether it's Outlook or Apple Calendar or whatever you use. And on that same page, the enercalc.com/office hours, on that same page, you can scroll down and you will find all of the unedited recordings of the previous office hour sessions. You can just, once you scroll down, you can see them here labeled. So for example, you can find the September session, which is with columns, or maybe the August session, designing steel beams for biaxial bending and so forth. So as we go through the months, we will be posting them here shortly after the live presentation, a few days after the live presentation. So moving on to the what's new in ENERCALC segment. And there have been quite a few worthy updates over the past few months, and I would like to quickly recap them for you so you're aware of the various new features that currently are at your disposal. First, decoupling of the IBC and the ASCE editions. Some jurisdictions started mixing and matching codes. So for example, a jurisdiction might be on IBC 2015, but they want to use ASCE 716 or 722. So They are not sticking to what that specific IBC references. Instead, they just kind of hopping around and grabbing different editions of the code. Now you are able to do that because beforehand, all of this used to be lumped up right here. So the IBC will have an ASCE right here with it. And now you have the ability to pick these two separately. And of course, you can pick different load combinations separately as well. So you can mix and match as you please and as the jurisdiction requires. The second update is the addition of new ASCE 722 modules. So we started with adding new tabs to the calculation menu. And the first tab, as you can see here, is seismic loads. We added two modules and one for seismic-based shear design and one for seismic wall anchorage. Next, we have the wind loads tab. We started already by implementing a calculation for the ASCE 722 wind enclosure. And the other wind load calculations, such as the component cladding or the envelope procedure for wind loads and wind pressures, they're actively under development and will be released soon. And when they are released, they will show up right here. Lastly, we have this new tab, which is named Other Loads. This currently includes a calculation for the ASCE 722 live load reduction, but in the future, it will also include other calculations such as snow loads. One of our most requested features is the ability to automatically link reactions from one calculation to another, and the ability to change something in one member and push one button to have the effects of that change trickle down to all of the supporting members, all of the downstream members. And ENERCALC has done just that with the native load linking feature that was released a few months ago. So you can see the new tab on the top called Calc Order. This tab organizes all of your calculations based on the load path order. You can see here that we have beam number 1 is first, and then after that we have the girder, then transfer girder 1, transfer girder 2. You can link multiple calculations from multiple members at the same time, and ENERCALC understands the load path logic and ensures that all the calculations are performed in the load path order based on the reactions or the loads that are being linked. We also added load linking status badges to help you navigate the status of each calculation and understand the warnings a little bit better. The new button at the very top is named Recalculate Linked Loads. This button allows you to bulk recalculate all of your calculations to ensure that the most up-to-date reactions are being used and their effects are trickling down to all of the related downstream members. We added a new tab that's inside your calculation. We added a new tab called Linked Loads. You can grab reactions from whatever calculations you already have created in that ENERCALC project file. And then as you actually cycle through, this is the list of the calculations that you already made. So as you cycle through this list of calculations, this 2D diagram changes to jog your memory a little bit about what this calculation looks like. So you can see the support, you can see the load, you can see a little bit of a 2D diagram or 2D sketch of that calculation. Below the diagram, you will see the support. So this is support 1, for example. This is support 2. And you can see the reactions, and you can click on whichever one you would like to grab so you can apply it onto your current beam or your current column or your current calculation. Next, you determine how you want that particular reaction to be applied to your current member. For example, if you want it to be applied at third points, then you can just choose this. You can, of course, specify a specific location, midspan. You can do a variety of things. Once you're good to go and you're, let's say we want it to be at third points, then you click on this button right here, the link load button, and the load will be linked. And this table right here summarizes all of the reactions that you linked into this current calculation. So if you grabbed reaction from multiple beams or multiple beams, for example, then you will see all of them listed right here. As you can see, for example, this shows that the placement is at 1/3 points, and you can, of course, clearly see that already being applied in the 2D sketch at the 1/3 points. So overall, load linking is a powerful and intuitive tool that allows the engineers to create a smart and well-connected chain of calculations, while, of course, minimizing the risk of transcription errors, as well as increase workflow efficiencies. So lastly, on this topic, if you go on ENERCALC's YouTube page and click on playlists, you will find a playlist dedicated to load linking. And you can see here, this one right here is the ENERCALC office hours. So this one has the recording of the office hours. This right here is the load linking playlist. And it's a simple and easy to follow playlist with step-by-step on how to use load linking. And of course, it also goes through the various workflows that you can implement. It also explains the status badges in great details and give the user a full, robust understanding of the capabilities of the load linking feature. So first video is a full overview, and the second video right here is just a short walkthrough of an example on how to use load linking. And video 3, 4, and 5 are a deep dive into all of the various functionalities. You can simply give this playlist to a new engineer or someone who's never done anything with load linking, and they will be able to fully understand and follow the instructions, and of course, learn more about the best practices of how to use this powerful tool. Next on what's new in ENERCALC, we have here ENERCALC for Revit. We have a new full gravity load path. So for those who don't know, a brief introduction of this is ENERCALC for Revit is a plugin that allows you to design structural members completely within Revit without relying on exporting or importing the analytical stick model. So what that means is that, this is taken directly from the ribbon bar in Revit, and you can just have this new plugin right here. It says ENERCALC, and you can see all of these. So previously, we used to support steel beams, steel composite beams, wood beams, and girders. And the new addition is we have steel column design and spread footing design, and this gives you a full gravity load path. So to see this in action, this is pretty much your Revit model. This is your new ribbon bar. You can just click on the steel column design. You pick the steel column that you want to design. You confirm the gravity support conditions. You look into and work with the slenderness in the X and the Y direction. Of course, pick your K value and all of that. And then the next step is the tributaries. So this automatically detects whatever beams they're being framed into the column. And what happens is that once you click OK, it automatically opens an ENERCALC calculation for you that's pre-populated with all of that information, including the column size and the reactions that came from Revit or came from the girder or the joist that's framing into it. So you can do all kinds of stuff in here, and once you're done and you click Save and Close, what this does is that it brings you back directly to Revit, update the size, turn it into green, and tells you, hey, this is good to go. And you can apply the same logic, the point and click logic for the foundation as well. And as you design a foundation, you click on it and it'll open this ENERCALC calculation for you. It grabs the reaction again, and you can come here, maybe change the size or change the reinforcement or do whatever adjustments, design adjustments you need to do. And then finally you click Save and Close. And what happens that it'll change the size for you. It'll update the status of the foundation. It'll also bring in the reinforcement information, as you can see here, which is, 8 number 6 each way, for example. So to get the most out of this, you can go for our user webpage. This is how you update regular ENERCALC, but if you scroll down on the same page, that's how you update ENERCALC for Revit. Just by clicking on this link, hyperlink right here, it'll download the Revit installer for you, and it will update it to the latest and greatest. And since the topic of today's presentation is wood shear walls, I figured it's a great time to introduce our next EFR, our next ENERCALC for Revit integration, and that is flexible diaphragm analysis within Revit. So you never have to manually calculate the loads they're being applied at your shear walls. So this will do the analysis for you. And this is still not released yet; it's still under active development. But I wanted to share with you a little bit about how it works. It's a simple point and click. So you can see here we have a brand new icon that says flexible diaphragm, and it's very simple controls, native control. It's a point and click, and it's a and it provides some interactive analysis. So you can just pick the diaphragm or the floor, and you can pick the loads that you have applied. And then you pick the lines of resistance. So in this case, let's just pick something simple, at the very edge of at every side of the wall or the building, and it takes the load, it runs the numbers for you, and it provides you with the reactions or the line load that's the point load that's going on top of each line of resistance. The flexible diaphragm tool is very robust because it does, of course, cantilever diaphragm, and it can handle multiple types of loads, and it can do a lot more. This is just a simple example, but it does a lot more analysis than this. But this is the overall idea. Next, our active subscribers can request a no-cost lunch and learn for their office. This can be an introduction to ENERCALC or discuss what's new in ENERCALC, or maybe learn more about how ENERCALC for Revit can expedite your design while optimizing your workflows or whatever you want us to discuss. You can request a lunch and learn by going to our website, enercalc.com, and then click for our users, get help, and then request a lunch and learn, and then simply just fill in this information right here, and one from our staff will reach out to you. Moving on, the focus of our session today is the design of wood shear walls and how you can use ENERCALC to expedite the process and make your life a little bit easier. So to start a calculation, you can follow the same familiar process, which is click on the Add button and then click on Walls, and of course, wood shear walls. And this opens up right here, which is the standard layout that we're all used to. So on the left-hand side, you can see the line of the resistance has two shear walls. So I want to start with this a little bit to identify what we're trying to do. We have a line of resistance that has this shear wall, which is panel 1, and this shear wall, which is panel 2, and they're split here by a door. So we want to design this using ENERCALC. We have to establish the geometry. The first panel is 8 feet wide, and then the door is 4 feet, and the second panel is 10 feet wide. And then the height is 10 feet, and the height of the door, I know it's not noted here, but the height of the door is 7 feet. So the total width of the is 22 feet. So on the right-hand side, which is this right here, you can see the wood shear wall module, and it's the first tab, which is the general tab. You can give your calculation a name, just like you normally do with all of your calculations. So let's call this shear wall 1, and total wall length. This is the full length of wall, and that is 22 feet. And I'm designing this wall to have stud spacing of 16-inch on center. Moving on to the next part, you can input the height of the shear wall, which is 10 feet. And you can add more floors by adding the height of each floor. So for example, if I go and I put maybe 12 right here, then that means the first floor is 10 feet, and then 12, that would be the second floor. And then another input area here will open, and then I can add more floors and so forth. But just for the sake of this example, so you can see how all this work, and we're going to go ahead and do just a single story shear wall. So then the next thing, you have to pick the seismic design category, and this is used to check if the selected sheathing is allowed for that seismic design category. I'm located here in Oklahoma, so we don't do a lot of seismic, and this example will be more wind focused. But to give you an idea, here in Oklahoma, typically a Category B is something that we see very often. So, assuming it's Category B, and then of course design methodology, you have ASD and LRFD. I'll use ASD for this example. The last portion of this page is dedicated to the framing material. And again, since I'm based in Oklahoma, Douglas fir South #2 is the material that we always, or most of the time, that's what we use. So you can select that wood material that works for you, of course, based on your region. And to pick that material, this is the same process that happens for wood beams and wood columns. So if you've used these modules, you should be familiar with it. And it's simply you click on this little button right here. And when you click on it, this window pops up and it has all of the reference design values for the various wood species included in the NDS. So you can pick the material that you want, then you click on select, and all of these values right here will auto populate for you. So now we move on to the next sheet, and now things kind of start to get a little bit more focused on the module that we're doing rather than being general. So this is the sheathing tab. First, we pick the sheathing and fastening pattern on the main side. We start by picking the correct table. So you have, we'll be picking 4.3A because that is the one that we typically use for structural applications, and that is the table for wood-based panels. 4.3B is gypsum sheathing. 4.3C is for gypsum and Portland cement plaster. And of course, 4.3D is for lumber shear walls. So again, for the sake of this example, you can do all of them. So whatever you have, that shouldn't be a problem. But for the sake of this example, we're sticking to the standard table 4.3 3A, which is the wood-based panels. So the next item we have is you select here the main sheathing from the menu. So you will find a list of all of the sheathing materials as shown in the NDS. And for our sake, for this example, we'll use the wood structural panel, 5/16 inch with 6D nails. And once you pick the sheathing material, the shear capacities right here are auto-populated based on that selection. So for example, for this example, we're using NDS 2015. So you can see the nominal capacities pulled up for wind and seismic. And those, of course, are the ASD, or those are the nominal capacities that we will use for our design for wind. So we're right here. That's the focus of today's work. So with that being said, we move on to the next part of this tab. So we have the option here to select if sheathing is blocked or not blocked. So for our example, it will be blocked, and this will matter, of course, in the check for the aspect ratios. So if it's blocked, you have a little bit better aspect ratios that you can use with reduction, of course. But for this case, we'll just use block sheathing. And this right here, we're not going to use this exception for the aspect ratio adjustment. So we're not going to worry about that. We'll keep that unchecked. If the wall has sheathing on one side only, then you can uncheck this option right here. If you just uncheck it, then that means the sheathing is only on the main side or on one side, and you're done. Now, if you do have sheathing on both sides, then you want to enable this option saying, okay, well, we want to apply sheathing on the other side. You will have another option here that says use same as main sheathing. So that means both sides will have the same thing, and now you just control it from here, and these values here will control both sides. Now, if you want to have something completely different, you can just come right here and say, okay, well, on the outside, maybe we'll have the 5/16 wood panels, but on the inside, I want to take some capacity from the chipboard or something. So you can kind of get two different materials for the sheathing. Again, for our example, we'll just use sheathing only on the main side. We are not going to add any sheathing here. But I just wanted you to know that you do have the ability to or some flexibility to do a little bit more and kind of use different materials and do exactly whatever you would need to do. So again, so yeah, that's why I unchecked this, and that's why all of this at the bottom here disappeared. Moving on to the next sheet, which is the chords. Sorry, not the sheet, but the next tab, and that's the chords tab. So now we determine the chord members. I'm picking 2x6 because that's what we're using for this building, and then you apply whatever CF factors. For this case, we're just keeping it as one, and we can use a maximum stress ratio for the chords in case we only want to load them up to 80% or whatever other hard limit that is established at your practice. So if you want a maximum, the maximum ratio you want it to be 0.8 or 0.7, you can always change that right here. For us, we'll just use the full capacity. Next, you can pick bracing conditions for the chord members from these two options here. So you can either pick fully braced about both axes, or you can pick that it is completely unbraced out of plane for the full height of the stud, while it is fully braced for in plane, which is the weak direction. This is the most common case that we have, and this is these options are a little bit simplified. So those are simplified bracing options that cover the most common cases. Now, if you have a bracing condition that is different than these two, and this is not cutting it for you, then you will need to design your chord members separately using the wood column module, which allows you to have a lot more control over the bracing conditions. But if your bracing conditions are within one of these two options, which most of the people will have that, then the chords will be designed here as well. Lastly, this part gives you more control over how you would like the vertical load to be addressed. You can check the box to only apply the vertical load on the chord based specific trip right here. So if you want the chord members to take only 12 inches or 16 inches of trip from that vertical load, then the vertical load, from that specific trip will be applied to the chord, not the full weight of the floor system or the roof or whatever. If you deselect this option, then the full vertical load from the whole panel will be applied to the chord member. So to give you a little bit more insight, the panel is 22 feet wide and 10 foot tall. By deselecting this option, the software will take the weight of the whole panel. So we'll take the weight of the panel and multiply it, take 22 feet times 10 times the weight of the panel. Let's say it's 10 PSF. And once it determines that full weight of the full panel, then it'll just divide it by 2. And the compression cord will take that as an additional compression load, in addition to the overturning compression load from the panel. Now, if you just want to say use a 16-inch trip, then it will only consider the vertical load from a 16-inch trip width and leave the rest of the vertical load to be applied to, of course, the middle studs. So this gives you a little bit of control on how you want to handle dead load. Typically, this is what I do in my own designs, but of course, every project is different and you can do whatever you need to do. But for us here, I typically use just a trip and call it good. So next, moving on to the openings tab. In this tab, you can define if your wall has any openings. So these openings are tabulated and labeled right here and can be modified at any time. In our example, we have a door opening that is 8 feet away. If you remember that right here, it's 8 feet away from the left side, and it's 4 feet wide and 7 feet tall. And it's very simple to add an opening. So all you need to do is just click on this add button, and this new window will pop up, and you can just populate this information: distance from the left edge, and opening width, and the opening height. Because this is a door, then this distance from the bottom is 0. But if this was a window, then you will put the distance between the bottom of window to the bottom of wall. So if this is, if it's 3 feet or whatever, then you just put that information here. Again, for us, this is just a door, so you can keep it that way. Now, I want to emphasize this now that we're talking about openings. The NDS defines three types for shear walls, and this is section 4.3.5. The first type, it's the individual full height. That is the standard shear wall that we all know, just a solid shear wall, and that is governed by this section right here, 4.3.5.1. Okay, so we're just going to focus on this last number, 0.1. And then if the shear wall has opening, then that will split into two different types. Type number one, it's called force transfer shear wall, and that's the one that is designed to transfer forces around the opening, and you have to do additional detailing to transfer the additional shear around the openings. And that is governed by this section right here, 4.3.5.2. This is something that ENERCALC currently does not do. The other type of shear walls that have openings in them, it's a midway method between an individual full height and between the full-on force transfer shear wall. It's called perforated shear walls. And this one right here is governed by 4.3.5 covered. But this, whenever you have an opening, the code tells you that, okay, you can just design these two panels as separate panels, which is the 5.1. So that's what ENERCALC is doing, is just taking these, designing them as separate panels. So this means that you will need to have, and this is the critical part, you will need to have 4 hold downs. If you used method 2 or method 3, you will only need these edge hold downs, and you wouldn't need any of these interior pieces. So if you use ENERCALC, you will need 4 hold downs, or 2 for each panel. So you can design each panel by itself, and you will get the same result. However, ENERCALC here helps save you a little bit of time by designing a full line of resistance at once. You don't have to come up with a little load here and design it by itself, and a little load here and design it by itself. You can just apply the full load here and put however many panels you have, and that load will be distributed based on the length of each panel, based on the PLF that's being applied to each panel, and you can get all of your chord forces, all of your design in one place. Now, of course, this assumes that you have the same sheathing conditions for all of them. So if you have something different for this panel than this panel, then you might have to design every panel separately. So now that we're done with the discussion on openings, we move on to loads. Moving on to the loads tab, first we click on the general subtab. We want the self-weight of the panel to be considered as vertical dead load. So you can uncheck this option to ignore the weight of the panel. So if you don't want it to be included, you can just uncheck it. But since we want the weight of the panel to help us a little bit, I check it, and I provided here weight of the panel of 7 PSF. So again, since our example here is focused on wind, we will uncheck the option to consider the weight of the panel as seismic load. If you check this option, you'll get to input some additional information such as CS and some additional stuff here. But since we're not using that, so I just moved on from it. Next, you have the other 2 subtabs, which is the vertical point load and vertical uniform load. So you have the option to apply these loads, maybe coming from floor or roof framing. So you can apply these loads. Again, in our example, so we don't just complicate things needlessly. In our example, we're not adding any additional load. We're only dealing with the current self-weight of the wall, but that's it. Next, the last 2 tabs allow the user to apply lateral point load as well as lateral uniform load. In our example, we will not use lateral uniform load. That would be something that's applied like that throughout the full height, or maybe partial, maybe half the height or something. We don't have this, but what we're going to be doing is applying a point load. We already calculated what our point loads are going to be for that line of resistance. And all we need to do is we need to apply that point load. And that point load is 4 kips and it is wind. So keep in mind, this example uses IBC 2015 and ASCE 710. So the 4 kips value here is ultimate. And the software will use the proper load combinations for wind load, which means, for example, it will multiply it by 0.6 if we're doing, D plus 0.6 wind combination. So just keep that in mind. We're using IBC 2015, and the wind loads are ultimate. So all of the applied loads will be tabulated and listed here for the user to review or modify or delete as needed. So those are here your controls. So if you want to add a new load, you follow the same process as we did for adding a new opening. So you just click on the add button. And once you click on this add button, you'll get this new window. You can say, okay, well, the load is at 10 feet and the wind load is 4 kips. You click OK, and that load will be applied, and you can see it graphically shown right here. The next tab is the footing tab, and this one is just a convenience thing. It is pretty convenient to have or to include some of that footing information within the shear wall module, so you can do a quick check of the footing as well, instead of having to take the reactions and try to design the footing by yourself. So in this tab, you can enter the various info that is needed for footing checks, such as footing geometry, bearing pressure, Fy, F prime C, and all that stuff. And of course, the footing, how much is it projecting outside of the boundaries of the shear wall. So if the footing is extending all the way here, maybe 1 or 2 feet, then you enter that, projection to the left and projection to the right and all of that. So the last tab is, in our calculation journey today, is the load combinations tab. We have the combinations already populated and ready to be used under the ASD load combination tab right here. But you can also turn them all on or off as you need. You can delete, modify, add more combinations. You can do anything you want. You can maybe, disallow some of them from running temporarily. So you have a lot of control over the combinations that you want to run. And if you click on this little tab right here that says load combination controls, you will find other filters that you can use quickly. So for example, you can turn off any combination that has anything to do with wind load. So you can just click on this, you get this, wind, you can say on or off. If you say off, it'll turn off whatever combination that has wind in it. And this is not unique to the shear wall module, but this is for all calculation modules that we have that have load combinations. There is also a separate load combination set that is being used for footing design. This is due to reinforced concrete, of course, being only supports LRFD design. So footing design, you can see here, it has its own set of combinations, which are the LRFD combinations, as you can see here, 1.2 and 1.4 dead and all that. So now that we've finished with the setting up of the calculation, let's look into some of the key results to assess if our current design is safe. First, let's check the panel summary to see if the sheathing works. So panel 1, which is P1, is the 8-foot panel, and panel 2, P2, is the 10-foot panel. You can see the applied shear is distributed based on the length of each wall. Hence, panel 1 takes lower shear than panel 2, and you can see it right here. The applied shear is distributed, again, based on the length, of course, of the panel. So that kind of helps out. And you can see that the PLF is the same for both of them, and of course the applied PLF. And again, that makes sense because the load got distributed based on the width of the panel, or the linear foot of each panel. You can also see that the ASD capacity of the sheathing that we picked is right here. That's the allowable capacity, 268.9. And you can see that the status is okay, and this is based on 6-inch at panel edges, the fastening of 6-inch at panel edges, and 12 inches in the field. So the sheathing is okay. And as you scroll horizontally, you're familiar with ENERCALC, so some of these results you have to scroll horizontally to see. And that's exactly what I did. I scrolled horizontally and took a screenshot. So as you scroll horizontally, you'll see more results, such as the aspect ratio of each panel, and making sure that it does meet code and it does not exceed the maximum allowed aspect ratio as noted in the NDS for a blocked shear wall. So you can see right here, ratio is okay, and that's the allowable for each panel per side, and that's the actual aspect ratio if you ever need to check that or need it for something else. So I want to note something about the allowable shear capacity that ENERCALC just calculated. So the safety factor, the omega factor for ASD design is 2, and this is based on NDS 2015. So this means that the capacity of the sheathing should be 560 divided by 2, and this gives us 280. However, ENERCALC here shows the capacity to be 268.9, which is of course less than 280. And this is because we selected the wood material for the framing to be Douglas fir South. And when using this material, the capacity of sheathing must be reduced based on the specific gravity of the framing members. So footnote number 3 in table 4.3a, where we have the sheathing information, it says that for wood species other than a Douglas fir larch and southern pine, the nominal shear value must be reduced by the factor below, which is 1 minus 0.5 minus g. And g is the specific gravity of the framing material. I grabbed this snippet from the general tab from ENERCALC. So Douglas fir South has a 0.4603 specific gravity. So if you plug that in, you get 0.9603. So if you take 0.9603 and multiply it by the 280, which is 560 over 2. If you multiply that, you'll get the 268.9, and that's why the capacity is reduced in this example. Moving on, let's check the chord forces. C1 and C2 are the chords for the first panel. You can see that C1 is in tension and the load that is applied to it is 1.33 kips. The design is governed by the tension, and the stress ratio is reported right here as 0.192. Also, you can see that the hold down uplift force is 1.05. The reason that the uplift force for the hold down is not the same as the tension on the cord is because the weight of the panel, as you work your way to the bottom of the shear wall, then now the weight of the panel accumulates and you actually reduce your uplift by the tributary of the weight of the panel. Now, if you chose the weight of the panel to not be considered at all, then the hold down uplift will be reported exactly as the actual uplift for the cord member. So this is just if you want to be conservative or however you want to deal with this, you have the ability to squeeze every little capacity you have, or you can just design your hold down directly for 1.33. The option is yours. And yeah, that's the same thing. So that's for the 105. And then the other part that we have to cover here is the C2, which is the max compression force in the cord, is the force from the shear wall, which is, from the shear wall couple, the tension compression, you have that, but also now the weight of the panel is additive to the compression. It helps you when it comes to uplift, but for compression, it actually adds to you, and that's why the compression is reported as 1.43. Evaluating panel number 2, C3 and C4 are the chords for the second panel. The same loading logic from panel 1 applies to panel 2. You can see that the uplift on the chord is 1.33 kips as expected, but of course, the force for the hold down is reduced, and this time it's you can see it reduced even further to 0.94. This is because the panel is wider. It's not 8 feet, but the panel is actually 10 feet, so there's more weight Now, this additional weight help resist uplift, so it helps you here, but it adds to your compression. So that's exactly the same logic. That's why we have a little bit more load on the compression and a little bit less load on the uplift, or on the hold down uplift sizing, um, for the hold down uplift sizing, yes. Lastly, let's quickly check the footing and stability tab. You'll find a lot of analysis information that would be helpful to help you assess the footing. Quickly to go through this, since this is not really the bulk of what we're trying to talk about today. Foundations is not the main topic, but at least when you click on the footing stability, you can see right here, for example, overturning ratio. You can see here soil pressure on the left side and on the right side. So those are analysis numbers, especially this one right here. This is an analysis number, so you need to make sure to compare that to your allowable bearing capacity of the soil. ENERCALC doesn't automatically check that for you. It just reports that number, and you need to make sure that you evaluate it. The stability ratio, it already does that for you, so you're good here, for example, and then it gives you a little bit more information about applied moment and shear and all of that to help you go through the process and evaluate, or at least preliminarily evaluate the foundation that you have chosen. So in summary, ENERCALC can design a wood shear wall that is subject to axial loads, of course, as well as the standard lateral in-plane loads. ENERCALC can design one-sided or two-sided shear walls, as well as the chord members for tension and compression, and gives you some pretty good control over how much you want to use of the dead load, and the ability to check some quick analysis for footing design, as well as overall footing stability within the shear wall module without having to go outside. So with that, now it's time for live Q&A from the audience.
All right. Thanks, Mac. Let's go ahead and hit some Q&A. So we had a question early on in the session. Are there any plans to add a feature to tie point loads together in the beam design modules? They're basically asking about moving loads. So the short answer to that question is no. ENERCALC itself doesn't have the capability to tackle moving loads right now, and I don't think we have any active development going on that right now. But you do have some capability in in ENERCALC 3D to tackle moving loads. So I'm going to drop a link in the chat to our help docs regarding moving loads with ENERCALC 3D, which you guys can reference to dive deeper on that. All right. Question from Jose. Can you also link shear, talking about load linking, Mac, can you also link shear wall overturning reactions from a beam? So do you want to talk a little bit about the roadmap and survey for load linking?
Yes. So let me show you guys here. So the way that we have this right now for load linking, that is only implemented in steel beams, and so from steel beam to another right now. But we want to implement it across all of our modules. The thing is that the order of development is tricky because we want to hear from our users which one is more important, so this way it gets developed first. So with that being said, you can see right here, if you open ENERCALC and you open a steel beam calculation and you click on linked loads and click on and can you see my screen right?
Yeah. Mm-hmm.
Okay, yeah, and you click on from columns, you see right here that says load linking survey. If you click on that, that will take you to the survey that we have. So this way you can tell us where you want the load to, the reaction to go from maybe a steel beam to a steel column, or from a masonry beam to a steel beam or something. So you'd have to tell us, and that will, however many times we get told, one specific module, that will get developed first. But the plan is to develop for all of them, is just the order of development. Right now, we're working on the development of linking wood beams. So that would be wood beam to wood beam, and wood beam to steel beam to wood beam, because the integration is going to be happening in all directions. So right now, it doesn't do that for shear walls. But if you take the survey, and you can take the survey as many times as you want. That will put you up in the in the leaderboard and allow us to develop it faster than other modules that are not being requested as much.
All right, next question. Does ENERCALC for Revit work on Revit LT or Revit Lite, as some people call it? So this is actually an Autodesk limitation. Autodesk themselves does not permit the use of third-party add-ins in Revit LT. And so in order to operate either ENERCALC for Revit or any other third-party add-in that integrates into Revit, you do have to be running a full license of ENERCALC, or excuse me, of Revit itself. So several people asked this question, so we can kind of tackle all of these at once regarding perforated walls or force transfer around openings. And Mac alluded to this in his presentation. Right now, ENERCALC only supports design of wood shear walls as individual segments, where each individual segment is subject to the NDS aspect ratio limitations. We definitely know this limitation is problematic for some design issues. So as our engineering team and our development team continue to grow, we definitely hope to address that limitation with new capabilities for perforated and FTAO. We don't have an explicit timeline that we're publicizing for that kind of capability, but it's very much on our radar, and it's something that it's an issue that we want to see addressed for our customers. And you can, if that's a big issue for you, if you haven't already, we definitely encourage you to reach out to the support team, support at enercalc.com, and go ahead and let the support team know that that's a feature you're interested in, because that's what allows us to set those development priorities. Let's see, another question. Is there any plan to have a module that will take the whole building and design shear walls, hold downs, etc., just like Woodworks software? So this is an interesting question, because ENERCALC has always had a focus primarily on being discrete component design. And that's why, what Mac is showing you guys today is discrete design of shear wall components within a system. You would have your lateral system analyzed separately by hand. So in general, we're not moving ENERCALC itself, especially the desktop structural engineering library, towards holistic system design. But with the stuff that Mac was showing you guys regarding ENERCALC for Revit, we are moving towards other more general capabilities where you have broad scope system analysis, you can distribute forces, and that will dovetail into Revit-based integration of lateral system design. For example, wood shear wall integration, where you can take a shear wall stack geometry from your Revit model, distribute forces to it using the flexible diaphragm tool, and so on. So not explicitly as such in ENERCALC itself, but we definitely are moving in a direction where you will have those kind of capabilities. Mac, this question will make you chuckle because we were just discussing this. The appearance of the shear wall on my screen is two segments shaded in gray with dashed diagonals, no wood grain displayed. Why is that? So we were discussing this issue with the engineering team, and so far the only way that the engineering team has been able to replicate that issue is if there's a specific JPEG file missing from your program files that is responsible for displaying that wood grain. If that's the case, you should be able to just go to our website and get the latest public release installer. And when you run that installer, all the files will be there, and that wood grain should appear properly. If that doesn't solve your problem, definitely reach out to the support team so that they can dive deeper and help diagnose that. Yeah, so we already addressed questions about force transfer around openings. If you're designing a segmental wall, if you deselect the box to apply the full vertical and wall weight to the shear panel, will the dead load be distributed to 4 chords? So basically, is the dead load distributing to all chords of the wall? Mac, you can go ahead and tackle that one. You are a little more up on
Where's
that particular
I'm trying
issue.
to see the question. I'm trying to read it. Select the box to apply the full vertical load and wall weight
Yeah.
to a shear panel. Is this the one? Trying to see which. Is this the option they're talking about? Because if this is the option right now, so if you deselect it, what it does, it takes the full weight of the panel. So if the panel is 20 feet by 10 feet by 10 PSF, it will take the full weight of that panel and divide it by two and dump the whole load, the whole weight into the cord. It's almost like saying that, if this is my panel right here, these studs, the middle, any of the weight of the panel, and that weight is being dumped only at the cord. It's almost like the whole thing is spanning. So that will add a lot of compression to the compression post, but definitely it will help almost too much with the uplift. So I would be careful on how to use that. But yes, that's exactly what it does. If you deselect this option, the way I do it, I select this option and say only take 16 inches worth of trip and use that to help you or to add to compression or to help you with uplift, but only using 16 inches or trip that you're comfortable with. I hope that answers the question. And each panel is being handled separately. So the weight of this panel over these two cords and the weight of the other panel over these two cords.
Perfect. Okay, next question. NDS has an exception where if the aspect ratio of a wall is exceeded, the shear capacity of that panel is reduced. Does ENERCALC consider the proportional reduction of the shear wall capacity if you don't exceed the absolute maximum?
That's correct. Yes, it allows you to, or it'll take the reduction based on that, based on the aspect ratio, but you still have the maximum that you can't exceed, which um, I believe for blocked shear wall that's like this, it's the 3.5, 1 to 3.5, which is exactly that's what we're showing here. The one to the 3.5 aspect ratio. So if you exceeded the two. So you see right here, this says the actual, this 1.25, and this is the one. And if you exceed the two, you're still allowed to go up to 3.5, but you're truncating some of that value or reducing some of the shear
Right,
capacity of the shear
because there's
wall.
the ratio for full capacity and then there's the shall not exceed
Yes,
ratio.
that's right. But yeah, this does it, is just, but the hard limit is the 3.5, if I remember correctly, so you can't exceed that, which I think that's what they alluded to at the end.
All right. Is the cord met the stud member at the edge of the shear wall? Yes. The cord is the boundary element at the edge of each segment that you're designing. That could be either single stud or I think you can do multiple stud gang also, correct?
Yes, absolutely, yeah.
Right. All right. Can you control the type of shear panel you design? Mac, did you want to jump back to selecting the type of shear
I want to
panel?
say, I want to just show this real quick right
Yeah.
here for the last person. So yes, so where you have these arrows, that's where you have your cord members. Please, very close. So what was the question? Sorry. Next question.
Can you control the type of shear panel you design?
Yes. So if you jump right here, first of all, you choose whichever stepwise table you want to use. This is the one that we typically use, the 4.3a, and that has the structural wood panels. You go right here and you see wood structural panels, structural 1, 516, various sizes and all that. This follows exactly the table in the NDS. So this one right here, the wood structural panels, sheathing 5/16, and you have that. And you can just, particle board, plywood siding, whatever, it's already included in the NDS. You'll find it right here. And whatever you click on it, it auto-populates these various nominal shear capacities for wind and seismic.
Perfect. Okay, where's the input for the tributary load of the floor diaphragm? You mentioned 10 feet, and I think, Mac, you can elaborate on this, but I believe the analysis is usually done separately. Mac was just alluding to the theoretical analysis that he had done to arrive at the forces applied to this particular line of resistance.
And yeah, that there isn't a way for you here to figure out, or from this within this module, there isn't a way for you to figure out what's the line load or the load that's applied to the line of resistance. So you have to figure out, if you have a square building and you have shear walls on the left and shear walls on the right, then you have to do your own analysis to figure out what is the maximum point load that's being applied uh, at the top of that line of resistance. Once you put that, then ENERCALC will take that load. So for example, right now the load, as you can see right here, this load, that is 4 kips, lateral point load right here. So the load is 4 kips and it's applied at 10 feet from the top because the panel height is 10 feet. So from 0 to the 10, so that's where it's applied. That load is 4 kips, but that load is then divided between these two panels. The way that that load is divided by the total length. So if this one is 10 feet, this will take more load than this one being, 8 feet, because eventually they all get the same PLF. Does that make sense what I'm trying to say here?
Yeah, for sure. All right, next question. Would ENERCALC consider adding Simpson hold down library to the wood shear wall module? This one's going to make Mac laugh as well. This is definitely something that we've talked a lot about with the engineering team, that we've also discussed with Simpson Strong Tie. We know that there's a lot of demand for engineers to be able to seamlessly specify fasteners, hold downs, and strapping products as part of the shear wall design. So we don't have a roadmap for something like that, but it's really something that we've been pushing on, trying to find out if there's feasibility to accomplish that. It's definitely something that's on our radar. Mac, do you have any further
Especially
thoughts on
that
that?
Simpson hold downs and just Simpson clips in general, and this is just not just Simpson, but wood in general. There's so many variabilities, and Simpson has a lot of products, and then of course seismic and wind, and then of course you have the base material and the the two types of materials getting together and all kinds of reductions. It's definitely quite a bit of work to do it, and it's just kind of finding the right way of implementing it. So um, I agree
Yeah,
with what Seth said. Yes.
for sure. Uh, Next question. How do you determine the assigned load to a specific shear wall? Is that a tributary load based on the total wind and shear load in that direction? So basically, what Kenneth's question is alluding to is diaphragm analysis. So it depends on the nature of your diaphragm. If you meet the qualifications from the code to be idealized as flexible, then you can do a flexible diaphragm analysis where conventionally you would distribute your lateral forces by tributary width of each individual resisting element. If you don't meet the qualifications for idealization as flexible, then you'd be looking at a rigid or semi-rigid analysis. You could go in ENERCALC 3D and do a rigid or semi-rigid analysis. You could go in ENERCALC itself and do a rigid diaphragm analysis. Or now that we're getting towards ENERCALC for Revit flexible diaphragm, you'd also have another avenue to analyze that. But fundamentally, it's the analysis of your diaphragm that determines the specific loads that are tributary to an individual lateral resisting element. And Mac, go ahead if you had more thoughts on that.
That's absolutely right. But yes, that's just it's going to vary so much how to determine what that load on top of your shear wall is. There's so many factors as you suggest.
Yeah, it depends on the geometry of the diaphragm itself, the flexibility or stiffness of the diaphragm, the geometry of the resisting elements, and so on. But
The
fundamentally,
location of the
diaphragm
resistance
analysis.
lines.
Yep. Okay. Question from Pavel. When you put tributary to the chords of a shear wall, is this applied trib for the reduction of the uplift as well? Um, Let me go ahead and tag this one so you can see it, Mac.
I see it. When you put tributary to the chord of the shear wall, is this applied trip to the reduction of the uplift? So when you check that we just talked about, that 16-inch or whatever, that's for compression loads. For uplift, we still actually use. This is a little bit tricky. So for uplift, remember I was talking earlier about we have two separate values. This is your pure uplift on the chord. But at the bottom of the stud, all the way at the bottom, we can safely take the weight of the panel because we already accumulated it at the bottom. So you can safely take the weight of that panel and reduce whatever you need for the hold down. However, the member itself will still experience at some point that 1.33. So to get to what he's saying, so now that we have this understanding, the trib with the 16 inches, that's only for the compression load that's being applied. But for the uplift, we actually take the full panel or, half of the full panel weight. So we take whatever tributary, not just the 16 inches, but we take, if the panel is 10 feet, we take 5 feet of that and say this way you only for your hold down design. It's not going to help you in the chord itself. Because again, if this panel has to accumulate the weight all the way down here. So, but this top portion of the chord of this stud right here might, it'll experience the tension right there. So you can't, some people say that you can't, rely on the weight of the panel, and you should only rely on the weight of the panel only at the very bottom where the weight of the panel has truly accumulated. But yes,
Perfect.
to answer your question, the 16-inch strip, that's only for compression. And as far as the uplift on the member is full thing. We don't reduce it at all. And the hold down is reduced by half of the width of the whole panel. So if the panel is 10 feet, then we take the weight of 5 feet.
And I just want to briefly mention to circle back to our discussion about shear wall aspect ratio. Our director of engineering, Chris Conrad, dropped a great link in the Q&A, and I dropped that over in chat for everybody to see. That clip that I shared, or that link, will take you to the flow chart in our help documents for the aspect ratio adjustment for wood shear walls. So check out that in the chat if you guys have more questions about that. Next question from Pavel. To have ENERCALC for Revit, you must have ENERCALC, or is it part of ENERCALC for Revit? Yeah, so good question. ENERCALC for Revit is an add-on to your regular ENERCALC subscription. So typically our customers already have ENERCALC. And then when you add ENERCALC for Revit to your subscription, then you get the installer to install the add-in that runs in Revit. And the add-in, the ENERCALC for Revit add-in, which runs in your Revit, just communicates with the normal desktop installation of ENERCALC that you would ordinarily use. Next question. Are overturning calculations based on centerline boundary post dimensions? And I think
They're
my
based on the
understanding
full
is that it's
width.
based on the out-to-out dimension, or the total
Yes,
out-to-out of the wall.
that's right. They're based on the full width. So if you model your shear wall, to be 10 feet, it will use the full 10 feet. It wouldn't reduce it by the thickness of the studs, or if you have your hold down somewhere, it doesn't look at that. It'll look at just the out.
Right. And it's never a good day when 3 inches from an inch and a half on each end will bust your shear wall. But I've been there where we've had to check it in design practice when I was designing 3-story apartment units and we had tall, skinny walls. You do have to check sometimes. So that's a good thing to know. Any future for the ASCE 722 addressing tornado design when you have risk cat 3 or higher? Not as far as I'm aware of at this time, but if that's something that you work with or something you're interested in, be sure to go ahead and send that over to the support team, the engineering team support at ENERCALC, so that they can make sure that that's on our list of feature requests. Because we're actively working on our 722 support right now. So if you have a specific question about that, be sure to go ahead and throw that out to the support team. Another question about perforated. So we addressed that a little bit earlier. No support for perforated or force transfer at this time, but it's definitely something that we're wanting in the future. Question from Tom. Does this webinar have continuing education credit? The answer is no right now for office hours, because the content varies. There's a lot of Q&A and housekeeping and information about software, that kind of stuff. But Mac, did you want to talk a little about future webinar opportunities that
That's
may
right.
include?
Yes, and we'll send out an email when we have the date for the first webinar. But we are working towards having webinars that they're certified to provide PDHs, and they will be a lot more technical in nature with even some work dot examples and code references.
Perfect. Let's see. Follow-up question from Pavel. Does the tributary apply only for the weight of the sheathing, or applies for all vertical loads on the shear wall?
The tributary, the 16-inch, that's only for for this right here, which is just the weight of the wall, not for the applied load. So if you have a uniform load from
A
from roof
superimposed load.
framing or something like that, that doesn't apply. This is just for the weight of the panel, and it uses whatever you input here as weight of panel.
Gotcha. Question from James. Using half of the panel weight seems flawed. A 100-foot long panel would not use 50 feet to help resist panel uplift. Do you want to go back to what you were talking about with the panel weight, Mac?
Yeah, so Seth, yeah, I guess if you have a shear wall that is a 100-foot long, probably, yeah, I wouldn't use this, but that's the whole point of this, is that you have the full capacity right here that's not reduced by the weight of anything. That this is your pure, if you do the calculation, this is the pure overturning force, which is the 1.33. If you don't want to reduce anything, you can either just use this number, or you can just simply say, hey, I don't want you to consider the weight or the self weight of the wall at all, and you can turn that off. You can just say, you know what, I only want to consider 2 pounds. You can do whatever you want to do. I think the main thing is that we try to provide you with the ability to, or the flexibility to do different things, and whatever you think is inconsistent or doesn't make sense, of course, yeah, you can override that and do what works best for your project.
Perfect. Okay, and then a final question. Is there any additional information one can look up regarding the design of the shear wall foundation? The wood shear wall module gives overall stability checks. It also gives maximum bearing pressure. So there's a few different ways you can go with that. You can size your width accordingly if your bearing pressure is too high. I've also worked on projects in the past where we were using our actual net hold down forces to figure a spot footing, square, rectangular spot footing. Mac, do you have any further thoughts on that one?
Um, I'm not sure. It's kind of, I just had a problem with my computer, but I'm not sure because as I said in my presentation earlier, like the meat of the presentation, the meat of this module is really the shear wall, not
Right.
necessarily the footing just gives you a guide. In my opinion, that's how I use it. It gives you a little bit of a guide on what you have or what you have in mind sounds like it's going to work. But I would still design the foundation separately because you're still not even getting like the full reinforcement stuff. You're only getting some information here about minimum reinforcement, but that doesn't mean that it actually works. So this is more, and that's why this is not really labeled as design, rather that's labeled, I guess, footing and stability to just kind of give you a little bit of a taste. Like, I mean, it doesn't even, it brings you here to the soil pressures, but you still have to manually compare that to your allowable soil bearing capacity. So I take this as just a starting a guide to say, okay, it seems like a 2.5 wide footing that's 16-inch deep and projecting 2 feet and 2 feet on either side. It seems like this is going to work, but I would still go and do a different and more rigorous analysis of the footing outside
Right.
of
And the
this.
follow-up question to clarify, it appears the longitudinal reinforcement is based on temperature and shrinkage steel.
Exactly.
Yes,
Yeah,
the module is not performing a rigorous flexural analysis or
it's not.
reinforced
It's
concrete
just
design of the
helping
footing.
out a little bit, but that's all it's
Yes.
doing. It's not really, and that's why you'll notice
It's
that a
it's
lot of
mainly there
these.
as a stability check.
Yes. And again, to me, this just tells me that, hey, this is a good starting point. I'm going to go do more design somewhere else, using some other module. And as always, you can just come right here to the loads tab, I believe, or sorry, yeah, the footing tab here, and you can just turn it off completely and it'll go away. So if there's something that, you don't want to be mixed up with, you can just turn it off and not worry about it at all.
Yeah. And Chris chimed in with a clarification as far as the behavior of the shear wall panel. The concept in the module is that the panel behaves as a rigid body. If that's not appropriate for your situation, then it should be rethought. Last question, back to the chords tab. Selecting, deselecting seems to apply to all vertical loads. Can you verify? Um, Feel free to reach out to the support team if you want to dive deeper on that selecting or deselecting box, and the support team would be happy to dive deeper on that one. All right. Well, I think that pretty much covers all of our Q&A for today. Mac, do you want to go ahead and leave us with some final thoughts about next month and scheduling and upcoming sessions and stuff?
Yes, the next month's session is going to be on November 13th, and the topic will be EFR, ENERCALC for Revit. It's been a long time coming, and a lot of people have asked for this, and this would be a good time to show the various capabilities of ENERCALC for Revit and how they integrate with ENERCALC, and how you can expedite a lot of your calculations and a lot of your design processes very quickly just by using ENERCALC for Revit. So that's what we're going to be doing next month.
Fantastic. All right. And as a final reminder, like Max said at the beginning of our session today, you can always go by our website, enercalc.com, and find the office hours page to sign up so that you can get reminders and register for upcoming sessions. And with that, we thank you everybody for being here. Thanks for all the great interaction and Q&A. If there was anyone who had a question that didn't get answered, absolutely feel free to send that over to the support team and get that addressed. And thank you all for being here. We'll look forward to seeing you guys next month.
Thank you.